asked to design and implement an LRU cache. Which has the methods get x, which is if it contains, return the value. If contains x, return value, else return -1. And set values x, y, which is if it has room, set x and y. If the cache does not have room, then remove least recently used data, which is where the LRU comes from, which is least recently used, and then set. So how I'm thinking about implementing this is with two dictionaries, one that contains the stored items, and the other that contains the key and when it was last used, and I'll need a counter to keep track of when it was last used. For the get method, I'm going to check if it's in the cache dictionary. If it is, I'm going to return the value and update when it was last used. And if no, I'm going to return -1. For the set method, I'm going to check if it's in the cache dictionary. If it's not already in the cache dictionary, I'm going to check, is there enough room? If there isn't enough room, then I will first make room by checking the dictionary with the last used, getting the last used item, and removing it. Then, then there will be enough room, and I will add the set value to the cache dictionary. If it's already there, I'm going to return a -1. The space for this implementation is 2n. The time for the get method is going to be constant time, it's going to be O of 1, and the time for the set method is going to be O of n, because if it is not in the cache and there's not enough room, we're going to need to loop through potentially every element in the dictionary to find which one was last used, which could be every element. So I created my two dictionaries and my counter to keep track of when the items are first used, or last used, I mean. I am going to, here's my get method. It returns an integer and takes in integer x. If I'm checking if the cache dictionary contains the key. If it does, we're going to return the value and check if the last used has that same key. If it does, we'll update it with the counter. If it doesn't, we'll add it using the value of the counter, and then we'll increase the counter. Else, we're returning -1. For the set method, we're taking in the x value, the y value, and the cache size. If the cache dictionary contains the key, does not contain the key, then we're going to check if if there's still room. If there isn't still room, we're going to set the minimum equal to the counter, since that is the maximum value we can have, and we are going to create a temporary variable so that we can get the key that's associated with whichever one is the minimum. So for each variable item in the last used dictionary, we're going to check if the value of that item is less than the minimum. If it is, we're going to set the minimum equal to that value, and we're going to set the temporary integer to that item so that we can then, after we go through this all, we should have the minimum value, which is the lowest counter, which means it was the least recently used because it was the least recently updated, since the counter increases every time a value is updated. So we'll remove it from the cache dictionary, and we'll remove it from the last used dictionary. Then we will add the given x and y value to the cache dictionary. We'll add the given x and the counter value, and then we'll increase the counter. If, in the other case, so if it already contains the key, then we're going to return -1.